So this is an interesting question. Here we have a tennis player. And so let's kind of draw a tennis deal. Here we have a net, and here we have our player. And she is hitting the ball. Let me make the ball red. She's hitting the ball here, and the gap that she hits here is 2 meters. And the height of the net is 1 meter. And the difference between here and here, where she's hitting from, is 7 meters. Now, we also know that when she's hitting the ball at an angle, and the angle is a very small 5 degrees. And she hits it with a speed of 20 meters per second. So you got the picture? And the question is, does the ball, if you think about it for a moment, I've drawn it so it looks like she's sure going to make it over the net, but it's possible that the 2 meters, it's going to cross and land down here, right? So we don't know what's going to happen, but we want to see if we can, well, figure it out. All right. What is the height of the ball when it is at the net? Well, that's going to tell you if it hits over the net, which is like question 2. So we've got to do some math, right? Obviously. So we'll just start with my tables. What do I know? I've got an x1, x2, v1x, a, and t. x1 is 0, x2 is 7, right? Because this is the x direction, right? v1x. Now, we do have to do some SOHCAHTOA games, right? So we've got 20 meters per second, and we got a 5 degrees. I've drawn it way bigger than 5 degrees. But the Vx is here, and the Vy is here. So you have to use SOHCAHTOA on that, right? So for the Vx, that'll be cosine. So I'll say 20 cosine of 5 degrees. And that number will go here, right? Acceleration is 0 in the x direction. The time, we don't know. And for y, y1 is 0. y2, we don't know. And actually, that's sort of the big question. We want to find what the y2 is at 7 meters, right? And then we'll say v1y, and that's going to be similar to this, except be 20 sine of 5 degrees, right? And so, what did I do? Let me think about this. Well, let's keep going. A is negative 9.8. So we're going to know these two numbers here and here from SOHCAHTOA and time. So what I did is I said, solve for v1y. No, I'm looking at the wrong question. Here we go. I solved for time using x. So the first thing I did is I solved for time using x, because since I know v1x, so usually we solve for time using y, so I can say x2 equals x1, yeah, that's how I did it, plus v1x plus 1/2 at squared. But remember, the acceleration is 0, so that drops off. We know what x2 is. x2 is at 7 meters. I'm just trying to find time. Equals 0 plus v1x times t, pardon me. And then whatever you got here, you'll plug down here, v1x times t. And you're going to have some number. That's going to solve for your time. That's the time at how long it will take to get to 7 meters. Got it? Now, once you know that, we're going to then utilize the same y equation, because what we're trying to find is y2. y2 is the big question we want to find. Basically, is it over 1 meters? So I'm going to say y2, I don't know that, it's my x, if you will, equals y1. Now y1 is 2 meters. It's 2 meters above the plane, plus, now we also know from up here, the v1y. So we know what v1y is. You'll have to plug that in. You'll know that number. Now times the time, and we do know the time from down here, plus 1/2 times negative 9.8, because A is negative 9.8 times our t squared. Again, that's the same t that we have here. And wada boom, bada bing, you're going to be able to solve for y2. And that is the answer. And you'll see if it's bigger than 1, then it goes over the net. And if it's less than 1, it doesn't go over the net. And I think it says how far above or below is the ball from the net. make that a positive answer when you do the key. So that's it.